Imagine for a moment you're taking a gigantic inventory of everything in your neighborhood. You count every house, every tree, every person, every car. But when you finish your tally, you discover something unsettling. Half of everything that should be there simply can't be found. The houses are there, you can see them. But half of the matter that should form these houses, these trees, these people, has simply vanished. Well, cosmic explorers, that's exactly the dilemma astronomers face when trying to inventory the universe. Half of all common matter, the stuff that forms stars, planets, and even you, is officially missing. Today, we're re-embarking on a fascinating cosmic investigation into one of modern astronomy's greatest mysteries, the problem of missing baryonic matter. You'll discover why scientists are desperately searching for half of the universe, what clues we've already found, and how the latest discoveries are finally helping us unravel this cosmic puzzle. Get ready for a surprising revelation about where this phantom matter might have been hiding for billions of years. Welcome, cosmic explorers, to Cosmic Frontiers. I'm your guide on this journey of discovery, and together we're building an incredible community of universe enthusiasts. We're on an exciting mission toward our first 1,000 cosmic explorers, and each one of you makes this journey even more special. To fully understand this mystery, we first need to get acquainted with our main character, baryonic matter. This name might sound intimidating, but it's actually quite simple. Baryonic matter is just an elegant term for common matter. All that matter made of protons and neutrons that forms atoms. In other words, it's the matter that makes up you, me, our planet, the stars, the planets, the galaxies, in short, everything we can see and touch in the universe. Imagine the universe is like a cosmic cake recipe. According to our best calculations, based on cosmic background radiation and other observations, this recipe should contain about 5% baryonic matter. That might seem like a small amount, but we're talking about a fundamental ingredient. Without it, there would be no stars, planets, or life as we know it. The rest of the recipe includes approximately 27% dark matter and 68% dark energy. But that's a topic for other videos. The problem arose when astronomers started doing their accounting. They knew exactly how much baryonic matter should exist in the universe based on observations of the Big Bang and primordial nucleosynthesis, the process that created the first chemical elements in the first minutes after the Big Bang. It was like having the perfect recipe and knowing exactly how many ingredients to use. But when they went out to actually count all this matter in the current universe, they found only half. Imagine if you were going to bake a cake and discovered that half the flour had simply evaporated from your kitchen. That's exactly what happened to astronomers. They counted all the stars, all the visible gas in galaxies, all the planets they could detect, all the matter in the form of cosmic dust, and half of the baryonic matter that should have been there was still missing. This wasn't a small calculation error or an instrument inaccuracy. It was a mystery on a cosmic scale that challenged our fundamental understanding of how the universe works. To give you an idea of the magnitude of this problem, we're talking about enough matter to form trillions and trillions of stars like our Sun that we simply couldn't find. For decades, this mystery tormented the scientific community. Where on Earth was half of the universe's common matter hiding? Were our models about the Big Bang wrong? Did we not properly understand how matter behaves on cosmic scales? Or was this matter right there, in front of us, but in such a subtle way that we couldn't detect it? The first important clue came from analyzing how matter is distributed in space. Scientists realized that, right after the Big Bang, matter didn't spread uniformly throughout the universe. Instead, it formed a structure that astronomers affectionately call the cosmic web. Imagine a gigantic three-dimensional spider web, where the threads are made of matter. At the intersections of these threads, where there's a higher concentration of matter, the galaxies we observe today formed. But here's the real kicker. Between these threads of the cosmic web, in the spaces we call the intergalactic medium, there should also be matter. Not in the form of brilliant stars or spectacular galaxies, but as an extremely diffuse and hot gas. This gas would be so rarefied that it would be like trying to find a few perfume molecules scattered across an entire football stadium. Let's use an analogy to better visualize this situation. Imagine you're at a house party with several people chatting in groups. The groups of people would be like galaxies, easy to see and count. But between these groups, scattered throughout the house, there are other people walking alone or in pairs, going to the bathroom, getting drinks in the kitchen. stepping out to smoke in the backyard. These dispersed people represent the missing baryonic matter. It's there, part of the party, but much harder to notice and count. The big question was, how do you detect something so diffuse and scattered? It was like trying to find invisible water vapor in a dark room using only a flashlight. Scientists needed much more sophisticated tools and completely new observation techniques. The first strategy was to look for light absorption. When light from distant objects travels through space until it reaches our telescopes, it passes through this diffuse matter. And when that happens, specific atoms absorb specific frequencies of light, creating spectral fingerprints that we can detect. It's as if the missing matter left footprints in the light we observe. Using this technique, astronomers began to find clues of the missing matter in the form of ionized hydrogen clouds scattered throughout intergalactic space. But it still wasn't enough to completely solve the mystery. It was like finding a few footprints in the sand, but still not seeing the owner of the feet. The big breakthrough came with the development of space-based X-ray telescopes. These revolutionary instruments allowed scientists to detect extremely hot gas. We're talking about temperatures of millions of degrees Celsius that emits radiation at X-ray frequencies. This hot, diffuse gas was invisible to traditional optical telescopes, but shone like a beacon for X-ray detectors. In 2018, two independent teams of scientists made an extraordinary discovery using this technique. They managed to detect gigantic filaments of hot gas connecting distant galaxies, exactly as predicted by the cosmic web models. It was like finally being able to see the invisible threads of a cosmic spiderweb that we always knew had to be there. But the most spectacular discovery came from a completely different technique: the use of fast radio bursts, or FRBs. These explosions are incredibly intense pulses of radio waves that last only a few milliseconds, but release more energy in a fraction of a second than our sun produces in several days. Here's the brilliant part. When these explosions travel through space until they reach Earth, they interact with all the matter they encounter along the way. Different frequencies of radio waves travel at slightly different speeds when passing through plasma, ionized gas, creating an effect called dispersion. By precisely measuring this dispersion effect, scientists can calculate exactly how much matter existed on the path between the explosion's source and our telescopes. It's as if FRBs are natural cosmic probes that traverse the universe, telling us exactly how much matter they encountered during their journey. In 2020, using this revolutionary technique, an international team of astronomers finally managed to detect the missing baryonic matter. They confirmed that it truly exists in the form of hot and extremely diffuse gas scattered throughout the spaces between galaxies. To give you an idea of how diffuse this gas is, its density is approximately 1 particle per cubic meter. Compare that to the density of the air you're breathing right now, which contains about 25 trillion molecules per cubic meter. It's like comparing a single ant lost in a football stadium to a crowd that completely fills the same stadium. The most recent observations, made with the Hubble Space Telescope and other state-of-the-art instruments, are mapping this missing matter in unprecedented detail. Scientists discovered that it forms a complex network of filaments that connect galaxies across unimaginable distances. Some of these filaments extend for hundreds of millions of light-years. To put it in perspective, our own galaxy, the Milky Way, is only 100,000 light-years in diameter. What makes these discoveries even more fascinating is that they confirm theoretical predictions made decades ago about how matter should be distributed in the universe. It's like solving a cosmic puzzle where the last piece finally fit perfectly, revealing the complete picture. Currently, new generation telescopes like the James Webb Space Telescope and ground-based observatories equipped with adaptive optics are allowing even more detailed observations of this diffuse matter. They are not only confirming its existence, but also studying its properties, temperature, chemical composition, and how it evolves over cosmic time. One of the most surprising discoveries is that this missing matter isn't simply static in space. It's in constant motion, flowing along the filaments of the cosmic web like invisible cosmic rivers. Sometimes it flows toward galaxies, providing raw material for the formation of new stars. Other times, it's expelled by galaxies through powerful galactic winds generated by supernova and black holes. Recapping our investigative journey, we discovered that half of the universe's common matter was hidden right under our noses. in the form of extremely hot and diffuse gas scattered throughout the spaces between galaxies. We saw how fast radio bursts became revolutionary detection tools, finally allowing us to find this phantom matter. And we learned that the universe is connected by an invisible cosmic web that transports matter and energy across incomprehensible distances. This discovery reveals something profound about our position in the cosmos. We don't exist on isolated islands of matter floating in the void. Instead, we are part of an interconnected network that extends throughout the entire observable universe. The matter that forms our bodies may have already traveled through these cosmic filaments, passed through other galaxies, and participated in the cosmic dance of creation and destruction for billions of years before finally condensing into the solar system we call home. When we look at the night sky, we don't just see isolated points of light. We see the visible nodes of a gigantic cosmic network, connected by invisible bridges of matter that we now know truly exist. We are truly children of the stars. But more than that, we are part of a cosmic web that unites the entire universe into a single, magnificently complex structure. Cosmic explorers. Now, I want to know, what impresses you most about this discovery? The fact that this matter was hidden right under our noses for so long, or the realization that we are connected to the entire universe through this invisible cosmic web? Share your thoughts in the comments. I love to hear how you process these cosmic revelations. And since we're talking about the mysteries of the universe, what cosmic enigma would you like me to discuss in the next video? Perhaps primordial black holes, the nature of dark energy, or maybe the possibility of parallel universes. Leave your suggestions in the comments. You are the ones who guide our journey of exploration. We're on an incredible journey toward our first 1,000 cosmic explorers. If this video expanded your horizons and sparked your curiosity about the mysteries of the universe, join our crew by clicking subscribe. Every new cosmic explorer brings us closer to our goal and makes our community even more special. Like this video if it illuminated the dark corners of cosmic knowledge, and share it with someone who is also fascinated by the secrets of the universe. Together, we are unraveling the mysteries of the cosmos, one discovery at a time. In the next video, we'll explore another fascinating enigma that challenges our understanding of reality. Until then, keep looking up, questioning the impossible, and remembering that we are all made of stardust connected by the grandest web that exists, the very structure of the universe.